recording. No, that's not right. Okay, that's right. Okay, so we learned early on about linear functions. Linear functions, when you graph it in the XY graph, you actually got just a line, right? Good.
Yep.
Now, for the quadratic function have this form is y equals to ax squared plus bx plus c. Now, this is different from this. Now, this one is called equation. Now, in this equation, this is called the quadratic equation. Quadratic. Now, in this equation, x has to take a certain value. So x actually is not variable. It's something we call unknown. So that's the confusing side because we use the same symbol for unknown and also for variable. But that's just because our language is limited, so we always have looking for the context. Now the context for this one is this is the equation. The x has to be certain value, cannot be any other value. Now here's different. Here's a function. Now in here, x is a variable, y is also a variable. X is called independent variable because every x we can take any value, but once x value is determined, then y is fixed. So y is called dependent variable. Good.
Yep.
So now with the quadratic function, we can do the graphing. Okay, and the graph actually is a parabola. Now, you probably have seen some parabolas in real life. For example, the satellite dish is actually bended over like that. That's actually parabola. Or if you have like a flashlight, or in the old days, you got flashlight like this, and you have something come up. And there's a light bulb here, and under that, that's also a kind of a mirror in the shape of parabola. Now, parabola has this property is if this is called focus. And now, if we use as a receiver, as a satellite receiver, all the radio waves, actually it's electromagnetic waves, and actually they converge on here. Doesn't matter how the line where that get in, it's always converge here. So that's why they use this shape. So the receiver actually is on here. So you got the focus. Now, if you use as a flashlight, is the other way around. Is the light bulb is on the focus, and the light, when they reflect it, they all move in a straight line like this. Okay.
Yep.
So for the quadratic function, it's actually either go like this way or going down like this way. Now, the simplest one is y equals to x squared. Now, how do we graph it? Well, one of which is have a table, and if x is 0, y will be 0. If x is 1, y will be 1. And if x is 2, y will be 4. And we can also looking at the negative side. -1 will be 1, -2 will also be 4. So if you graph this one, now we so this is a point, is 1 point. And we also 1, 1, 1, 1 will be here. Then 2 will be 4, will be right here. And we can see that on -1, we got 1, -2 is 4. So the graph we got actually is going to be looking like this. Good.
Yep.
And if you write as y minus -x squared, and if you plug in, then you'll get a line like this, which is all the way around. You got line like this. Good?
Yep.
Yeah. So this is called concave up. This is called concave down. And as long as the first leading coefficient is positive, A is positive, then it's always concave up. And if A is negative, then always concave down. Good?
Is that for the equation or like any equation that you have if it's
No, just
the
for
first?
this one, just for this quadratic function.
Oh, okay. Yep.
Good? And this actually just the special a special example, because in this case, our A is 1, our B is 0, our C is 0. And on this one, our A is -1, B is 0, C is 0. And you can see that when A is negative, it's going to be concave down. But if A is positive, it's concave up. Good?
Yep.
Now, when we're doing quadratic functions, there are certain properties. One is that it has a vertex. So in this case, is the lowest point. And they also, in this case, the vertex is highest point. And what's special about the quadratic function is if you put a vertical line go through the vertex point, then this side and that side just mirror image. So they are perfectly symmetrical around this this line. This line is called axis of symmetry. And sometimes we just write that AOS. And same thing here. If you put the line go through the vertex point, then the left side and the right-hand side, they are perfectly symmetrical. And of course, we see this vertex point, and in this case, this is the lowest point. This is called minimum. And this point is called maximum. So we have some kind of vocabularies here. Good?
Yep.
So now we have to calculate the vertex point. We have a formula. So we know our function is ax squared plus bx plus c. And this point, we actually give a special symbol for that. We call this point h comma k. So H is the X coordinate of this point. K is the Y coordinate of this point. So H, then the formula is minus B over 2A. K is 4AC minus B squared minus 4A. And okay, so if we know the function, we know the A and B and C, then we'll be able to calculate the vertex point. Like, for example, if this one is y equals to x squared plus 2x minus 3, then our A is 1, our B is 2, our C is -3. So H will be minus B is 2, over 2A is 2 times 1, will be -1. And our K is 4AC, 4, and 1 times -3 minus B squared, which is 2 squared, over 4A, which is 1. That gives us minus 12 minus 4 over 4. And then we got -16 over 4. We'll get -4. So if you want to graph this one, we know that our vertex point is -1, -4, 1, 2, 3, 4. So it's here. So now this line is our axis symmetry. And we write as x equal to -1. So now when we're talking about xy coordinate, then x equal to -1 actually is a line, it's a vertical line. It's not a single value. And again, the context is important. Under this context, x minus 1 is a line like this. Okay, so now we know they are symmetrical. So we already know 1 point. We just need to know 2 more, then we can graph this. Okay.
Where did you? I understood everything, I think, but where did you get your first point from? Where in the equation that you did you get it?
Well, we based on this vertex point. Okay.
Okay, is the h equals -2 over
2A.
2?
That's the formula here.
Oh, okay, so that's your formula for the.
Right.
Okay.
And K is this formula. Good.
Yep.
Okay. So we know our first point. Good question. -1 and -4. We find it. And we needed 2 more. Then we can make because of symmetry, then if we know 2 more, that means we will get 4, because the other side is symmetrical. So what we're going to do here, we're going to find the y intercept. Now y-intercept is when x equal to 0. So in this case, then we know y will be -3. So it'll be here. We need 1 more. Well, we just pick one. So we can say what is x when x equal to 1, then we know it's 1 squared plus 2, because 2 times 1 is 1, minus 3, and then we got 0. So we got another point here. So therefore, based on the symmetry, we should get 1 here. And this is 1, 2, 1, 2 be here. So therefore, we can just graph like that. Good?
Yep.
All right. Okay. Let's do some exercise. First, let's find the vertex point. let's see, y equals to x squared minus 3x plus 2. Okay, so we know our h is minus b over 2a. Our k is 4ac minus b squared over 4a. Let's see what you got, okay? You can type on the chat.
You want me to put it in the chat or just tell you?
Yeah, just put on the chat.
Okay.
Well, let's see how we do this one. Our h, don't forget, is minus b over 2a. What is our b here? We know our a is 1.
3.
B actually is -3 because negative in front. And c is 2. Good?
Yep.
So that will be minus -3 over 2 times 1. So it's 3 over 2. And then we're looking at k. K is 4ac, 4a is 1, c is 2, and minus 3, so squared. So b is -3, so -3 squared. And 4a is 1, so we got this part is 8, this part is 9, and 4. So we got -1/4. Good?
Okay, yeah, so I did get the bottom one. I accidentally didn't have it as a negative, but I got the bottom one. I just thought since it's 1/4, it'd just be 1, but
Well,
apparently not.
yeah, has to be -1/4.
Okay. And
All right.
then I'm a little bit confused on the top one. Uh, your answer is 3/2, or does it simplify down?
This one?
Yeah.
Well, just negative, negative, positive, and that's where we go. You can do 3/2, or you can do 1.5. Really doesn't matter. Just
Oh,
different.
okay. Yeah. Yeah. I'd understand it better with 1.5.
Oh, that's fine.
Okay. Thank you.
No problem. Okay. Let's do y is x squared plus 4x minus 5. And see what you got. Okay, very good. So we know h is minus b over 2a. Our b is 4, 2 times 1, so that is negative 2. And our k is 4ac. This is a is 1, c is negative 5, minus 4 squared. And then we go 4 times 1. So the top one here is, this give us negative 20, and this other side is minus 16, and over 4. So we got negative 36 over 4. Now, negative 36 is negative 9, so we should be equal to negative 9. Good?
Yep, I see what I did wrong. When I put in my numbers for 4AC, I put 4AB, and then B, I made it C. So I
Okay.
flip-flopped those two.
Okay, all right. Yeah, just need more practice on that. Okay. It's looking at, just write down here. H is minus B over 2A. Okay, is 4AC minus B squared over 4A. So Y is X squared minus 6X plus 5. And see what you got. Yeah, very good. Is on the H, be careful with the sign. It's negative B over 2A. We know B is negative 6. So that's 2 times 1. Then negative, negative, positive. So 6 over 2. That's give us 3. Good.
Why did you change it to a positive?
Well, B is a negative number. So negative, negative is positive.
Oh, okay. So if there's already a negative or a negative before it, it
Yeah.
cancels it to
Well,
positive.
negative times negative 1 times negative 1 is equal to what?
Positive one.
Yeah. So I mean negative, negative, positive. Good.
Okay. Yep.
Canceling is that when they multiplying, then negative times negative become positive. When you got negative 2 times negative 3, that's positive 6. Good.
Okay. Yep. Thank you.
Very good. So now okay, I'm going to show you another way to find the K. One is by the formula. Another one is just plug in the H, because H comma K, that's the vertex, either here or here. Since it's a vertex, it's on is part of the function. So therefore, if you plug into here, plug in h, in this case, our h should be 3. Then we plug into this function. That means our x will be 3. We plug that in. So y, so in this case, k would equal to h squared minus 6h plus 5. So we got 3 squared minus 6 times 3 plus 5 is 9 minus 18 plus 5, negative 9 plus 5 give us negative 4. Good?
Why did you make the 9 negative?
9 negative, oh, 8 minus 18 is negative 9.
Oh, okay. And so then, okay, yep, that makes sense.
Okay, so this is the reason for we can do that is because this point is on the graph, and which means that this point is will satisfy this equation. If you plug in h, then you should get k. Good.
Yep.
So it's sometimes easier this way versus this. Both are good. Um, and sometimes when the function is simpler, you plug in a number. That's you can do that a little bit easier. Okay, let's do one more. Y x x squared plus 6x and minus 7.
Could you write the key down again so I can write it down on my paper?
You mean the formula?
Yeah, the formula. That's what. Thank you.
Okay, let's see. You got h, that's good. That's 6 over 2 times 1 is -3. Now, if we use plug in to the function, we got -3 squared plus 6 times -3 minus 7. And this will be 9. -18 minus 7. There'll be negative, this gives us -9, and this will be a -7, so get -16. And if we want to use the formula, we got 4AC, A is 1, C is -7, so we get positive, negative, negative, minus 6 squared over 4 times 1. So on the top, what we got? -28 minus 36 over 4. And we got negative 64 divided by 4. That gave us -16. Good.
Yep, I just did the formula wrong. I see that now, and I don't know why I did it that way, but yep, that
Okay.
makes sense.
Very good. Very good. So now, you probably can see there is a similarity between h and this is minus b over 2a, and there's a k equals to 4ac minus b squared over 4a. Now, remember, if we have, this is for the function. Now, when the function intercepts the y-axis, then at this point, y is 0. So at these 2 points, the function becomes an equation that is ax squared plus bx plus c equal to 0, just for these 2 points. Okay, and we know that these 2 points we can use the quadratic formula. It's minus b plus minus b squared plus minus 4ac. Now you can see something similar, 4ac minus b over 2a. And this, you can see this is minus b over 2a plus minus this part. So, and this is our, you can see this x1 is minus b over 2a minus b squared minus 4ac over 2a. The second point is that plus that b squared minus 4ac 2a. Now, if we add x1 plus xb2, this term got canceled, right? One is negative, one is positive. And then that equals to minus b over a. If you take the average, we just get, then that will be divided by 2. That will give you negative b over 2a. So this is exactly our vertex point. So basically this says that when you have the x, this is actually called x-intercept. You got x-intercept of this function on the x-axis. The average between these 2 points is right in the middle, and that is your vertex point. Good?
Yep.
Okay, so this just show you the relationship between the vertex and the x-intercept. Now, the x-intercept is really the solution to this quadratic equation. And you can see how everything got tied together. Okay, now, I'm going to show you one example. Y equals to x squared plus 4x minus 5. And now we know our vertex point is minus b over 2a. That will be minus 4 over 2 times 1. That give us minus 2. And our k, then I can just plug in the number, plus 4, negative 2, minus 5, and that give us 4 minus 8 minus 5, and that give us negative 4, negative 5 equal negative 9. So if I want to show where it is, then we can see that it's on negative 2, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll be done here. And we also know the y-intercept is negative 5, which is that. So 1, 2, 3, 4, 5. And we also know 2 points based on the quadratic formula. That is minus b plus minus b squared minus 4ac over 2a. And that gave us 2. This is a minus 4 plus minus b squared is 16 minus 4ac. Our a is 1, c is negative 5. So we got negative 4 plus minus 16 plus 20 over 2. That is negative 4 plus minus 36 over 2. That is negative 4 plus minus 6 over 2. So we got two numbers. X1 is negative 4 minus 6 over 2. That is negative 5. Other one is minus 4 plus 6 over 2. That is 2 over 2 is 1. So we know that there's a y-intercept here and also the negative 5. Okay, negative 1, negative 2, 3, 4, 5. This is another one. And you can see that this is our axis symmetry. And this is 1, 2, 3, 1, 2, 3. Symmetrical. There's two x intercept. And we know there's is y-intercept. So we go back to 2 here, which is symmetrical to here. And then we just got those 4 points. Then we can connect them. Then we just graph this function. Good?
Yep, it all made sense. I'll just have to do it a couple times to try to get it.
Right, right. Very good. So right now, not only we can calculate the vertex point, and we know how to do the y-intercept. That's easy. Just set x to 0. And we also know how to find out the y-intercept, those 2 points, which are symmetrical around this axis symmetry. And you can see that the vertex point, the y, the x in coordinate a vertex point, just right in the middle between these two x-intercepts. So that's now we got everything together. We got function, we got equation, we got vertex formula, we got the quadratic formula. So that's pretty much everything we need to know about the quadratic functions. Good?
Yep.
Okay, I'll let you try a couple. X squared plus 2x minus 3. So you need to figure out the h and k, or we just plug in. K is, we call this as a function of h. This we can write this as a function. That's a function, just means y is a function of x. And then the quadratic formula. Good?
Yep, and this is done in order. You find H first and then K. And with the two Ks there, that's just two different ways of finding the
Right,
same.
right.
Okay.
Yeah,
And then you find X.
right.
Okay.
Yeah, actually, it doesn't matter which one go first, but you need to find all of them.
Okay.
H, K, and X. Good?
Yep.
Well, let's see, okay? Our h is minus b over 2a. Our a is 1, b is 2, and c is -3. So minus 2 over 2, that's minus 1. Good? Yeah, Matthew, over here.
Hang on, let me see what I did wrong real quick.
Okay.
Okay, yep.
Okay. So now our k then, if we plug in the value, will be -1 squared plus 2, -1 minus 3. So we got 1 minus 2 minus 3. That's 1 minus 2 is -1 minus 3 got -4. Good?
Yep, and then just having H off is what threw off the next one, so.
Right. And now
Yep.
we got this minus b is -2 plus minus b squared is 2 squared minus 4ac, 4 times 1 times c, -3, and over 2a, which is 2 times 1. So now we got -2 plus minus. This is at 4, and negative times negative positive, so it give us 12. Then we got 2, and that is -2 plus minus 16 over
Um,
2.
I have a question.
Yeah,
For the go down a little bit to the 4 plus 12, why did it turn to positive?
well, we got negative here. We got
Yep.
negative here. So negative times negative, because our C is negative. Okay?
Okay, but wouldn't it be 1 times -3 times 4?
Yeah, will be -12. Okay? 4 times 1
Oh,
times -3 will be -12, right?
yes.
Then we have negative outside. So negative times negative is positive.
Okay. Okay, yep, that makes sense. Yep.
Okay, very good. So now then we got -2 plus -4 over 2. So we got two solutions. One is -2 minus 4 over 2. So it'll be -6 over 2 is -3. The another one is -2 plus 4 over 2. That would be 2 over 2 equals to 1. Good? Yeah, we good, Matthew?
Yep, I think so. I only got one of the x's right. Then I got the -1.
Well, actually, it's
Or
1,
no, it's a positive
-3.
one.
Yeah, it's +1. +1, -3. Well, just practice, okay?
Yep.
All right. So I'll see you next week.
Yep. See you next week. Thank you.
You're welcome. Bye.
Bye.